We're on Chapter 2, Section 2.6, Part 2. Solve using algebra, define a variable, write an equation, solve, and check. So this is a mixture problem. Number 3, how many cups of juice that is 13% apple juice should be mixed with 30 cups of juice that is 18% apple juice to get a mixture that is 16% apple juice. So what we're doing here is we're taking two concentrations of apple juice and mixing them together to get a concentration somewhere in between. So we have a 13% and 18%. So what we want to do is draw a little picture of that. So these are different concentrations. And we're going to put it all together and make a big mixture. Okay, so we have like the weaker concentration, which is the 13%, and we're going to mix that with some 18%, and our mixture is going to be 16%. So what I do is I write that percent at the bottom as a decimal. So this will represent 13%, this is 18%, and 16% written as a decimal. Now, what we're concerned with at the beginning is how much actual juice, that means with the water, sugar, whatever else is in there, is in each of these containers. So it says how many cups of juice that is 13%. Well, we don't know that, but we're mixing it with 30 cups of juice that is 18%. So we do know there are 30 cups here. So we don't know what's there, so let's let that be our variable. Let's call that x. So if you're pouring in X cups of juice with 30 cups of juice, these are getting poured together in the large mixture. You add what's inside each container. So there's X plus 30 cups of juice in that container. All right, now we have to think about how much actual juice, pure apple juice, is in each container. So 13% of X, right? That's how much actual juice is in this container. For instance, if you had 100 cups and you were able to extract the pure apple juice, there would be 13% of 100 or 13 cups. So that's the second part, is to think about the pure juice, pure apple juice in each container. So the pure apple juice here is 0.13 X, and the pure apple juice here is 18% of 30. We actually can figure out exactly what number that is. And the amount of juice here is 16% of the entire container. The entire container has X plus 30 cups of juice. All right, now, so the question is, these two from the first two vats get combined, and then you should have the same amount of pure apple juice once you put them in the big container. It's not like all of a sudden you have more apple juice, pure apple juice in the container after mixing it. So this is your equation. The pure apple juice from the first container plus the pure apple juice from the second container is exactly the same amount of pure apple juice in the mixture. And this becomes our equation. So if you draw a picture of it, it kind of hopefully makes sense to you. It's sort of like if you extracted this, it would just be a little bit of juice, right? Like 13%, it'd be a very tiny amount of juice. You might even get a little picture here. And let's see if I can do this correct. I guess it's medium. Just a little bit of juice. That little yellow part, that's more than 13%, but you get the idea. And then, there's some more juice over here. And so there'd be more juice in the bigger container, right? So the yellow you could think of is the pure amount of juice in each container. It isn't really accurate, but you get the basic idea. Okay, so now let's go back to solving this equation. Now there are two ways to solve this. What you could do is eliminate the decimals first, or you can go ahead and work all the way through with the decimals. The way I learned how to do this was to eliminate the decimals first because I didn't have a calculator when I took algebra. So I'm still sort of in that mode. So I'm going to multiply both sides of the equation by 100. And if you do that, then in each term you could move the decimal over 2 places. Multiply by 100. So if I have 100 times 0.13, that'll give me 13x because I'd move the decimal place 2. And over here you would move one of the numbers 2 places. You may as well do the one with the decimal in it. Don't multiply the 30 times 100 as well because then you're multiplying times 100 and the other thing times 100. There's no distributive property here. And same thing here on the outside. You may as well multiply that by 100, changing to 16, x plus 30. Now if you work this problem completely with decimals, using your calculator, you should get the same answer that I get at the end of the problem. All right, so let's see. I just like to work without decimals. So 13x plus 18 times 30 is 540. And then we have 16 times x is 16x. And 16 times 30 is 480. And by the way, I chose to multiply by 100 because I had to move 2 places to the right. That's the most I had to move the decimal point in any one of these terms. So that's the least common denominator if you had written this as a fraction, 13 over 100, 18 over 100, 16 over 100. Okay, so here we are. 13x plus 540 equals 16x plus 480. And I'm going to get the variables on one side. I'm going to go ahead and put the variables on the right so it's positive. Again, more than one way to do it, but I'm going to keep the variables on the right so that I've got 3x on this side, which means I want to subtract 480 as well. All right, so 540 minus 480, I think that's 60. And now we can divide by 3 and get x equals 20. All right, so now we have to remember what x stood for, what the problem was asking for to begin with, and we need to do the check. All right, so this was our original problem and how we set it up, the picture, and then we found x is 20. So let's just draw a picture again and see what that would look like. Now that we know that x is 20, well, put in 20 for x. We already knew this was 30, and 20 plus 30 then will be 50 in this container that we're mixing. And the percent in each was the 0.13, the 0.18, and the 0.16, 13%, 18%, and 16%. And now we want to check and make sure that the amount of apple juice in each the first two containers when added together is the same as that over here. So we could just check what is 13% of 20 and what is 18% of 30 and what is 16% of 50, and we're going to see if we add these together, is it really the same number? In other words, do we really have the same amount of pure apple juice? All right, at this point, you get out your calculator because you're really just going to simplify. This is the check, basically. So don't add something to both sides of the equation. So we have to do 13 times, let me see, 0.13 times 20. And you could do that using a calculator or in your head, but it's going to be 2.6. And we have to do 0.18 times 30, and that gives you 5.4. So if you add 2.6 plus 5.4, that gives you 8. So I know there are 8 cups of pure apple juice in the first two containers. Now, on the other hand, I want to end up with 16% of pure apple juice in the mixture. So 16% of 50, if you figure that out, it's 8. So yes, you do have the same amount of apple juice in each. Another way to do this is to say, well, you've got 13% of 20 is 2.6. That's how much apple juice. So we're again checking the pure juice. Different ways of writing the problem. And you also have 18% of 30 cups, which is 5.4, and when you add that up you get 8.0, and then you're checking that against 16% of 50 equals 8.0, and these match. Alright, so the answer to the problem, remember, you have to remember what the question was. How many cups of juice that is 13%? So in this case it was really what we solved for x. Use 20 cups of 13% juice. And that's that.